Okay, I've got the top of the hour on my clock, so we are going to get started. Welcome, everyone. Thank you so much for taking the time to join me today. Today, we are going to be talking about improving paved and unpaved roads using the GeoWeb 3D soil confinement system. So let's get started. So I'm your host, Sam Justice, and I am a licensed professional engineer in the states of Wisconsin and Kentucky, and I have degrees in both civil and geotechnical engineering. I'm one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluation from our in-house design engineering team, like me. So a couple learning objectives. Here's some of the things that I hope you get out of today's presentation. So understand the benefits of using a soil stabilization system such as the GeoWeb system for both paved and unpaved roads, including the ability to use local low-quality fill, reducing your overall cross-section, and building roads over soft subgrades. Then also learn about how the GeoWeb system reduces the vertical pressures and potential subbase movements, and how to utilize unpaved gravel surfaces for positive environmental impacts. So a couple different things we're all covering today. So let's get started. So a little bit of background on Presto Geosystems, who we are. So we worked with the U.S. Army Corps of Engineers to develop the GeoCell technology in the late 1970s and have been innovating in the geosynthetics market ever since. Our products have been used in over 200 countries and in every state in the United States. We go beyond simply providing a product, all with an eye for providing a complete solution for your project. So we do operate in three main product areas. The first is going to be soil stabilization using our GeoWeb GeoCells. Those can be used for load support, slope and channel protection, and constructing green retaining walls. Then we also operate in the porous pavement market, which we have both vegetated and aggregate solutions, and with lightweight, reusable construction mats. So today we are going to be focusing on the GeoWeb GeoCells, and in particular how they apply to road projects with load support solutions. So if you're interested in one of these other applications that I mentioned, feel free to reach out to us directly or go to our vast library of webinars where we've talked about some of these other topics. So let's start with how the GeoWeb stabilization system can provide benefits for both paved and unpaved surfaces. So the GeoWeb system is our version of the GeoCell technology, and it consists of two main attributes. The first is going to be the cell or the container size. The cells do come in three diameters, small, medium, and large, and have cell heights of 3, 4, 6, 8, and 12 inches, so 5 different options there. And the dimensions are going to be dependent on your project details and your vehicle loading requirements. So we can help you determine which one will be the most appropriate for a specific job. There are also 5 section lengths to best fit your project needs. So moral of this story is there is no one right size. There's no single product that we sell, put out in the market and say it works for everybody. We have a couple different options that are going to give you the best solution for your specific project. So something else I want to point out is going to be the ultrasonically welded seam. And that's going to be where all of the connecting points are. And it's very important to the function of a GeoCell. The stronger the seam strength, the better the performance that the GeoCell will have. A strong seam allows for heavier infill materials, steeper slopes if you are on one, and better overall lifetime performance. The GeoWeb system is produced using high-quality virgin high-density polyethylene, HDPE resin. And this gives consistently strong welds at every cell junction, while also maintaining semi-rigid ductile properties within the cell walls, and offers high-stress crack resistance and overall toughness and long-term durability in the environment. So our GeoCells do not use any fillers or exotic polymer alloy blends, anything like that, because they can ultimately reduce your weld strength and your environmental stress crack resistance. And those sorts of things, those fillers, those alloys, are usually offered in some of our competing products in the name of increasing cell wall stiffness. But you do want to avoid that because you don't want weld failures or differential settlement. And that can happen if you increase just the cell wall stiffness to the detriment of your welds. So what you really want is going to be uniformity in the performance across all elements of a geocell system, rather than focusing on a single parameter alone. So I mentioned there were two main attributes. The second one is actually going to be the infill material. So it's going to be what you put into every one of those containers. An important benefit of the GeoWeb system is that even a low quality aggregate, a sand, or even certain salvaged materials such as recycled concrete can be used to infill the cells. Using salvage aggregate or sands can save a significant amount of money on both material and hauling costs. Or you could potentially eliminate the fines of your material because the cells themselves, the actual GeoWeb panels, provide the confinement and aid in compaction of those cohesionless soils. When you don't have fines, you can significantly improve the drainage of the system and let water flow freely through the system, preventing poor pressure buildup and global failure across the cross section. The ability to use sands and low quality aggregates really sets the 3D GeoWeb system apart from things like planar geogrids or geotextiles. Both of those types of products require the use of high quality materials with very high friction angles to achieve their optimal performance. With the GeoWeb system, low friction angle materials are just fine. The GeoWeb panels still achieve their full potential even when using poor quality materials. So good cost savings options there. So in order for a geocell to perform uniformly, and that's really the key word that I want you to take away from all of this is uniformity, is that it's critical for both the factory welded junctions, so those ultrasonically welded seams that I mentioned earlier, and the field joined junctions that connect the individual panels, we're going to talk about those in a minute, perform at a level that's commensurate with the cell walls. So that's three primary elements of a geocell system. You've got the cell walls, the internal junctions, and the connecting system. And they all must perform uniformly as a complete system. Therefore, an incremental improvement in a single characteristic, such as the cell wall stiffness, is only valuable if there's a complementary improvement that's made in the other two components of the system. The GeoWeb panels, as I mentioned, are manufactured using a proprietary blend of high-quality virgin HDPE. So our proprietary formulation has stood the test of time for more than 40 years, and it contains no fillers, no unstable polymer combinations, and no exotic alloy blends. For most typical sites, the GeoWeb panels are going to retain its durability for greater than 50 years, with lab testing indicating around 150 years with no degradation, even at full exposure to the elements. So we stand behind our numbers so you can deliver certainty in the solution as you build with materials that you can trust. And something that is on a lot of people's minds nowadays are microplastics. And so because the GeoWeb panels are made with high stability inert materials, that HDPE is completely inert, it means you're going to have a permanent stabilization solution, and it's not going to degrade, leach, or release microplastics into your environment. So because it doesn't have any fillers or compatostabilizers or alloy blends, anything like that, it is purely high density polyethylene. And it is going to be the same material that's used for other environmental applications, such as geomembranes and environmental barriers. So to protect against that spread of harmful toxins, our products have been third-party tested by accredited geosynthetic laboratories, confirming long-term stability against environmental factors such as weathering and oxidation. So it is predicted to be durable for more than 100 years in the natural soil. So that is something that we really want to sort of emphasize and reassure you of, is that you are putting a stable solution into the ground. You're not going to be including something that has the potential to contaminate your ground or your groundwater system. You don't have to worry about that with the GeoWeb system. And the GeoWeb system and all of our accessories are 100% made in the United States under strict quality assurance and environmental control processes. So this is especially important if perhaps you're working on a federal project. We are Build America, Buy America approved. And so we are going to be acceptable to all of those types of requirements. So definitely a good thing to have. Okay, so we've talked about the actual GeoWeb panels, but I've mentioned a couple times there are some accessories that we include to help make this a complete system solution. And so these are going to be all of the components that help the GeoWeb panels protect the road surface and subbase layers and ensure a uniform performance of your interconnected system, protecting against the damaging effects of non-uniform deformation or differential settlement in response to applied loads. So let's look at a typical cross-section for a load support application. So we start with your subbase, can have varying strength. Typically it's expressed as the California bearing ratio with a CBR as a percentage, but you can have some other values as well. And then we decide whether or not you need a planar geosynthetic material, such as a woven or a non-woven geotextile. This is going to be based on what your specific application is. Typically, if you are in perhaps a very wet environment or a very clay environment, having a geotextile there has some additional benefits. So then you potentially need a subbase of aggregate, usually. So it can be aggregate, it can be sand, it can be that salvaged, recycled material. And then you're going to place the GeoWeb panels either on top of your subbase layer or on top of the natural subgrade, depending on what layers are necessary. You're going to put in your desired infill material, whether it's stone, sand, what have you. And then you are going to typically want to have what we call a wearing course. This can either be loose aggregate or it can be something like asphalt or concrete if you need a paved surface. And then you apply your load on top of that. So it's pretty important to realize that all of these components work together to support your load. So that's why you have a cross section that looks something like this. So here you can see some of the stresses on the subgrade due to an unsupported subgrade on the left-hand side and then a GeoWeb reinforced section on the right. So you can see how there's pretty much a complete elimination of the highest stresses, the red and the orange stress levels, when you have the GeoWeb reinforcement. The stresses are reduced and then distributed over a wider area as well. So we call this the mattress effect. So the mattress effect reduces the stress that's reaching the subgrade and leads to a significant decrease in the deflection and rutting of the system overall. So getting a little bit deeper into how that works, the GeoWeb geocells can alter the geometry of the soil pressure bulb beneath the applied load through that mattress effect. And so that soil pressure bulb is the stress level that we saw in just that previous slide. So when the load is applied to a geocell reinforced layer, the lateral earth pressures develop within the infill material, which is confined laterally by the geocell walls against movement, in turn developing an upward shear resistance along the wall interfaces throughout the interconnected network of the cells. So it's a lot of words, but in essence, this lateral confinement converts the horizontal earth pressures into upward resisting shear forces. When combined with a suitable base reinforcement, it becomes possible to construct over very weak subgrade materials, including those with standard penetration resistance, so your SPT N values of less than 2 blows per foot, which is a CBR of about 0.5%. So very, very low, very soft subgrades. And this is going to be a place where most planar geosynthetics, such as a GeoGrid, would otherwise fail. So this is a really sort of unique application. If you have these incredibly soft areas, the GeoWeb system is going to have a great solution that you might otherwise not have. So the material that's confined within GeoWeb panels cannot be pushed to the sides or overly compacted the way that freely placed stones would be. And so by eliminating this lateral particle movement, the GeoWeb system can stabilize the surface, eliminating the need for constant maintenance. You're not having to come back in and constantly fill in ruts, fill in gaps, anything like that, because they're just not going to form. So here you can see the impressive load support benefits of an 80,000 pound loaded dump truck. And so this is the standard AASHTO H20 loading parameters. This is going to be applicable to highways, including all sort of emergency vehicle access, so fully loaded fire trucks, ambulances, and fully loaded dump trucks. And so you can see this is a partially filled GeoWeb panel over a soft substrate. And you can see how the cells push back against each other to support that load. And really only the adjacent cell needs to be filled to maintain that support. So a great benefit to using the GeoWeb system is that you don't actually have to have every cell completely filled in before the road becomes usable. So you can reduce your construction time and materials needed with this approach, all with about half the thickness of your cross-section required by traditional methods to support the same load. So benefits all around. So the purpose of cellular confinement of the GeoWeb system is pretty simple. It's to stabilize the movement of unstable soils, both horizontally and vertically. The weaker you have of subgrade conditions, the more practical it is to insert the GeoWeb system into the design. It's an engineered system that has the best confinement and subgrade stress reduction in the industry. So like I said, although today's discussion is going to focus on the GeoWeb system for load support just for roads, other infrastructure applications, including intermodal yards, rail ballast reinforcement, and then things like slope reinforcement, bridge approaches, vegetated swales, and even vertical MSE walls are possible with the GeoWeb system. We're just not talking about them today. So with all of that sort of idea of how the GeoWeb system works, let's describe how the GeoWeb system works when it's at the surface to create the stabilized, unpaved road, or basically a gravel pavement. So an aggregate surface has advantages both in cost savings and with the GeoWeb system, when it's filled with an open graded base course, allows you to design a system that has stormwater infiltration and even provides stormwater storage. So site access roads, both temporary and permanent, are a really common application using the GeoWeb system. This project was created to access oil resources over undeveloped, soft, spongy subgrades. And notice how there's a really heavy, loaded vehicle driving on the GeoWeb system immediately after infilling to finish infilling further along the road. So you can drive on your road as your access road while you're building it. So you don't need temporary access roads built to the side just for construction. So definitely a huge construction time saver. And in a similar way, the 3D structure of the GeoWeb panels works well for building things like work paths, especially in remote areas where things like clean aggregate is going to be scarce. The compact GeoWeb sections are actually shipped or can be shipped directly to your project site. They come palletized. So there's going to be less trucks for transporting road building materials, less hauling emissions, and then you can use your on-site salvaged material as the infill so that you don't have to bring in that clean aggregate from off-site. So readily available on-site sand, poor quality aggregates, and even that recycled material, if you had crushed concrete, say, can be used in place of expensive gradation aggregate that you would have to transport in. So that's just something that we really want to emphasize. It's a really key factor in how the GeoWeb system can give you cost savings, time savings, that sort of thing. And in most cases, the GeoWeb system can also reduce the depth of your cross-section by 50%. So, massive savings there as well. So this was a project for a sawmill in British Columbia up in Canada. Spring snowmelt and fall rains typically were causing flooding in this area, creating soft, challenging soil conditions for the infeed area for the mill. So Presto worked with the owners to develop a design to manage both stormwater and snowmelt while providing stabilization and support of the heavy loads over a soft subgrade. In this case, they chose to use a 6-inch deep GeoWeb load support system, and they included a high-strength woven geotextile. That was designed to help promote stormwater infiltration. This is something that, this is a good place to sort of mention why you might use a geotextile. And really, you're going to include one when you do have these really soft soils, because including the geotextile helps prevent over compaction and sort of punching into your soft soil environments. It helps spread the load, helps create that mattress effect. So it kind of acts like a snowshoe. So if you think as you're walking through the snow, your single foot is going to punch through the snow. It's going to be hard to get back out. You wear a snowshoe, helps spread the load. You don't sink into the snow. The same thing happens with the GeoWeb system. By spreading out the load, including that geotextile underneath, you're spreading out the stress on the subgrade. You're not going to get punching failures. You're not going to get those shearing failures into those really soft subgrades. That allows you to have this load support where otherwise you might not be able to. And so the GeoWeb system does provide a strong reinforcement layer for those constant heavy loads. So when you know that you're going to have heavy daily traffic, in this case, fully loaded trucks bringing logs into the sawmill, this is a good way to make sure that you don't have to constantly be going back and replacing and regrading the access road. The GeoWeb system is going to be a permanent, a long-term solution. And the GeoWeb panels do create a smooth platform that is capable of eliminating the rutting and that constant maintenance. And both project owners and installers are usually pretty happy with the ease and speed of installation, thanks to our specially patented ATRA connectors. Those are going to be our mechanical junctions. Those are the keys that connect all of the individual panels together. So here's another site access project. This was for Duke Energy down in Florida, and it was to install new transmission towers through a wetland area. In this case, the high winds of Hurricane Michael had demolished over 100 towers, all of which had to be restored over this extremely soft subgrade. So you can see how easily footprints are being formed, how quickly a person sinks through here. Imagine driving heavy vehicles trying to install, massive equipment like transmission towers over this soft subgrade. So the GeoWeb system was used for both access and permanent maintenance roads, as well as actually the pads for the transmission towers themselves. And so the saturated sand, the natural subgrade of this wetland, couldn't really support any type of vehicle load. So again, they chose to use a woven geotextile over the subgrade. This allows for that water infiltration movement so that you don't have to disrupt the water flow of a wetland area, and adds that a little bit of extra strength and prevents that punching failure into your soft subgrade. And it's not going to get clogged by your sandy material. And then the GeoWeb panels are then placed on top of that woven geotextile, in this case, filled in with a poor quality aggregate that was close on hand so that they didn't have to bring in expensive, engineered material. And it was easily sourced and transported to the area. So once those panels, the GeoWeb panels, are actually filled in, both wheeled and tracked equipment can drive over to the system. So even when the material is sand or that other low quality stone that you might have, which would normally be horrible to try and drive tracked equipment over, totally easy to use with the GeoWeb system. And again, you can see how the GeoWeb panels act as their own access road. Just keep filling up the cells in front of you. No need for those additional temporary. So here's another typical problem that we would see. So this was at a bulk material handling yard, and it consisted of these telehandlers creating really deep ruts over a soft subgrade. And the rutting develops due to that lack of confinement, so the material can just get pushed to the side, overly compacted, shoved around by the vehicle tires as the cars are moving back and forth. So you're constantly having to go back, regrade it, try and smooth out the surface so that the telehandlers have the ability to move forward. And so this project consisted of 100-ton reach stackers, which caused that severe subgrade or severe rutting on the subgrade. In this case, it was even a CBR of 3%. So it's a pretty common soil strength for sandy areas, not really that soft, but when you have incredibly heavy loads, such as a reach stacker, it can still be just not strong enough. So the reach stackers were only able to make a few passes before that subgrade started to fail. And so they were having to regrade and do surface maintenance daily. So we worked with the engineer for this project to come up with a solution consisting of the 8-inch deep GeoWeb panels to support the loading. So that GeoWeb system confines that material, controls shearing along both lateral and vertical movement to eliminate that rutting and try and reduce all of that constant daily maintenance. And then here you can see the final solution with the GeoWeb system supporting the load. The GeoWeb layer confines the infill, giving it strength and essentially eliminating that potential for rutting. And we do typically recommend a 2-inch wearing course of stone on top of the GeoWeb panel. And this is just for protection against impacts from vehicle tires and loads. So whatever you fill in with the material, you just overfill by about 2 inches. So if you, in this case, they use the 8-inch panel, you overfill it by 2 inches, so you've got a 10-inch total cross section. Then one last application here. This is a storage yard in Mexico for the Kansas City Railroad. The original design called for 16 inches of reinforced concrete, but the cost was way over budget, as one can imagine, and the railroad was looking for a value engineering solution. So we worked closely with the engineer to come up with a GeoWeb solution to eliminate for that concrete wear surface, but still able to support 80-ton reach stacker loadings. So in this case, the design consisted of the 6-inch deep GeoWeb and a 4-inch wear surface over the top. So that's going to be a 10-inch total cross section. So you can imagine going from 16 inches of reinforced concrete down to 10 inches of just stone. That's going to be a massive savings. And so we do want to help you get the best design for your site. We're not here to just sell you something and then disappear. We're going to be with you throughout the whole process. So you can see how the GeoWeb panels are being infilled, in this case with crushed limestone. And the fines content here was kept around 20%. This allowed for some water infiltration into the subbase, and even it was able to keep some storage of stormwater within the cross section. This is a good photo to show that infilling process. So the haul trucks can basically just dump the aggregate into large piles, and it's not actually going to damage the GeoWeb panels. And then with a front end loader or similar equipment, the stone is pushed into the empty cells while the equipment drives on the infilled areas. And then workers can either hand rake the stone into the cells to make sure that they're fully filled, or just keep pushing in with that equipment. It's a fast and efficient process. It doesn't take any additional training or expertise on behalf of your contractors. So you don't have to have specialty contractors. You're not spending a lot of extra time training them on the system. It's pretty easy to figure out as soon as you get started. And in terms of compaction of this material, you don't actually have to do significant compaction. So you push the stone into the cells, and then you have that wear surface, so that overfilling of the material over the panels. And as you're driving just your regular vehicles, or if you do want to put a smooth barrel roller compactor over the top of it, you roll that over the top, you drive over the top of it, and that vehicle movement compacts the stone into the GeoWeb panels themselves. So you get that compaction over time as you're using the GeoWeb supported road. So you don't have to do significant compaction of thin layers, and you don't have to worry about going into every individual cell and trying to compact. You do it as a whole after that wear surface has been placed. So you can see the final wearing surface here. And so this is going to provide nice solid surface to support the load, minimal maintenance required. In this case, they chose to include an asphalt tack coat as a surface stabilizer. So while the GeoWeb panels themselves do help prevent movement or shifting of the aggregate, if you do want that little just extra peace of mind, adding a surface layer of asphalt tack coat or a low strength cement grout, something like that, can be used to ensure there's absolutely zero movement of the stone. Definitely still works with the GeoWeb system. It is a little bit extra on top for peace of mind. It is not required. So just for a little bit of easy visual comparison for how much the GeoWeb system can reduce your pavement cross section, this graph shows the unreinforced depth, which is in blue, compared to the GeoWeb protected depth in green, the lower one, over a lifetime of passes. So for a high traffic yard with 1 million lifetime passes, the GeoWeb system saves nearly 2 feet in total cross section. So fantastic amount of savings. Now I do want to switch for just a minute and cover some of the environmental aspects of using the GeoWeb system for unpaved roads acting sort of as porous pavements. So stormwater regulations are becoming increasingly common, and owners may choose to focus on meeting specific goals based on your site conditions. We've seen how the GeoWeb system can help with poor site soil. It can also help when there's a focus on sustainable solutions and managing your stormwater on site. So by utilizing the GeoWeb aggregate surface system, you're making the best use of valuable high-cost land and have the ability to meet your green goals and initiatives. So reducing a site's overall environmental impact can help you meet green infrastructure, low impact development, or other green building goals for building in protected or densely populated areas. It can also help you meet stormwater requirements that limit the amount of hard surface, such as asphalt or concrete, in your landscaping plans, which is an increasingly common requirement in large cities and in areas with protected waterways. So for permeable pavement, this was a project where the local stormwater regulations limited the amount of hard surface paving. So in order to expand their parking lot, this business turned to the GeoWeb system with a permeable infill. So the sections were filled with an aggregate with a very low fines content to create this porous pavement that allowed the water to drain naturally. The aggregate allows infiltration when that fines content is low, think around 10% or less usually, so those void spaces between the stones stay open and allow for free water movement. This was also a project that used the GeoWeb load support system to help protect a wetlands area while meeting stormwater regulations for the amount of runoff potential into the surrounding area. So this was an environmentally sensitive place, it was a wetlands, so minimizing both the construction impact and the overall lifetime impact of the road was very important. So using an open graded stone allows for that water movement through the GeoWeb system so that the water cycle in the area is not disturbed. And by using a slightly deeper cross section of the base rock underneath the road and parking area, the GeoWeb system was able to retain nearly 3 inches of stormwater per event. So that greatly reduces the runoff potential, and for this particular site, meant that an above ground retention pond was not needed. So huge cost savings there. So the GeoWeb panels are both strong and stable, and that's a very important feature when you're trying to reduce your overall impact to the areas around you. By being able to reduce your cross section, less excavation is needed, so there's less disturbance to the installation process. By reducing the overall lifetime maintenance, there's less chance for vehicle encroachment on the vegetation around your roadway. A washed or clear stone, so where you have that really minimal fines content, is used to create those stable, permeable, low impact development access roads. And site access roads, both temporary and permanent, are, like I said, a really common application of the GeoWeb system. So as mentioned, really heavy loads can drive on that system so that you can get to wherever you need to, including both tracked and wheeled equipment, without having to build excessively large roads or have high runoff potential from hard surface roads. So with GeoWeb panels, you can create what is essentially a bridge over that soft, wet ground. So it's where you're going to sort of cover that wetlands area and create that mattress effect so that you don't have that punching into your wetlands area. Those saturated soils typically can't support any type of vehicle load. So with the GeoWeb system being able to then be able to bring in that AASHTO H20 loading, your full emergency vehicle loads, highway rated loads, that can be a great way to get that in there. And like I said, those clear stones, the washed minimal fines content is what really is going to allow you to have that water flow. And the GeoWeb system can be a great option for extending your road shoulders along all types of roadways, including highways. And so you can actually fill it in with stone for an aggregate shoulder, or you can fill it in with what we call engineered fill, which is a mixture of aggregate and topsoil. It allows for full vegetation growth while still supporting those full vehicle loads. So you can use this to widen your roads, and it can help manage stormwater runoff from your asphalt or concrete roadway by collecting that water and allowing it to infiltrate without running off and potentially gathering in a side area or needing, big drainage swales to collect and move that water. You can just infiltrate it naturally into your groundwater system. So pavements that do allow for water to flow through the surface into your base course can reduce the requirements for stormwater storage at the surface. This is a sort of local regulation. You do need to check with your local stormwater regulation to confirm that they'll allow something like this, but storing water underground is a great sort of option to not have to build big retention ponds at the surface. And so the porosity and how much storage ability you have within your porous pavement is going to be project dependent, but it is something that we can help you determine, and we can help you with your local stormwater regulations as well. And now I want to, again, we're going to switch gears, go back to how the GeoWeb system can help, but this time it's going to be underneath pavements. So no longer a gravel surface, but now we're talking asphalt, concrete, any sort of hard surface roadway. So the GeoWeb system can be used both in place of or in conjunction with your traditional aggregate layer that would be placed beneath your asphalt or concrete road surface. So that same mattress effect from the GeoWeb panels that we had been discussing still applies here, with the system helping to bridge soft soils and adding strength to your weak subgrades. When it's used as a base layer, those stiffening effects create that nice uniform system. That's what we like to hear, uniformity. And that's going to be translated up through the surface layer. So it's going to keep paved surfaces stable and in place, reducing your overall maintenance requirements. And you can still get that thinner cross section of your base layer, usually 50% is what we like to aim for, which means that there's going to be less excavation required on site. That's going to be great if you do have like shallow public utilities. This was a replacement of a roadway through a small downtown. And so they obviously didn't want to have deep excavation because they already had things like water pipes, utilities, all sorts of things underground that they didn't want to have to mess with. And so you can actually place your asphalt layer directly on top of the GeoWeb panels, and you can place it again before you finish paving the entire road. So again, you can have that sort of nice staggered construction, and you don't need to have cure times. You don't need any special equipment. Your standard asphalt paving equipment is going to do the trick. And like I said, all those nice benefits still apply when it's used as a base layer rather than the surface layer. You can still use those low quality aggregates or sandy materials, so you don't need to bring in that difficult or expensive stone. And that stress reduction from the panels will still reduce the potential for deformation or settlement when placed over soft soils. So you're not going to see things like alligator cracking or wheel ruts or potholes. All of that stuff, it's not going to form at the surface because you have a nice strong base layer. And that strong base layer means a strong surface layer, which means longer pavement lifetimes with less maintenance or section replacement. So I'm sure everybody has seen this, driven over this, hates this sort of problem. So an unstable base underneath your hard pavements over time is going to lead to rutting, settlement, potholes, pavement degradation, and potentially total pavement failure. Bad drainage is a possible cause, but the most likely culprit is going to be buildup of poor water pressures underneath your pavement. Reducing and keeping those pore pressures low is a key factor in pavement design with the GeoWeb system. And the positive effect of the GeoWeb system in the pavement base layer is the extended pavement life and lower maintenance requirements. So, pretty common problem that we see here. I'm sure we've all dealt with roads like this. So surface cracking, ruts, lots of patched up areas that seem to start failing almost immediately. This is what happens when the road is built over that weak base layer that can't fully support the vehicle traffic. With the GeoWeb system, the failed asphalt and base layers are removed, the GeoWeb panels are laid down and filled in with a granular material, and then you have a fresh paved surface over top of the panels. Now you've got a good strong base leading to a strong surface It's going to look cleaner. It's going to last a lot longer. No, lot less patching and maintenance required. Everyone comes out happy in the end. So the GeoWeb system can be used under all types of roadways, from private drives to full service highways, like this project for the New Mexico State Highway and Transportation Department. So they were unable to proceed on a timely basis with any sort of conventional alternative, such as deep excavation with really thick base layers. They even considered using chemical stabilizers on the extremely soft subgrade, but eventually the DOT turned to the Presto GeoWeb system. The local sand material was used as the infill with the 6-inch deep GeoWeb system underneath a standard asphalt pavement. So this was a nearly 200,000 square foot project, and it went into the ground quickly and inexpensively, solving the DOT's budget and construction issues. This was another project for Union Pacific Railroad out in San Francisco, California. So this was an auto storage yard for cars being offloaded from overseas. So the original design included multiple layers of geogrids with a really high quality aggregate. When construction started, the subgrade was discovered to be even wetter and softer than anticipated, and so the geogrid solution was no longer effective. The local engineer contacted us to provide a value engineered solution using the GeoWeb system. So we worked closely with both the engineer and the railroad to provide our solution. And it consisted of a woven geotextile, again, used because it was this incredibly wet, soft subgrade, and then a 6-inch base layer and a 6-inch deep GeoWeb panel. So the base layer provided some additional load support, but also an area for water to move underneath that final asphalt surface to help prevent poor pressure buildup. So this was definitely something they wanted to keep in mind. They knew that the area was very wet and soft. They didn't have any dewatering capabilities. So having this open graded base course allowed for free water movement without causing, heave up into their hard surface asphalt pavement. So here you can see all of the expanded GeoWeb panels and the open graded fill being placed into those panels. As I mentioned before, it's easy to see how that installation process would go. So the workers would expand the GeoWeb panels, connecting every individual panel with our Etcher keys to create a continuous system that covers the entire area. And then the infilling comes behind them, filling in the cells from those large piles of stone. Again, you can use things like front end loaders, or you can get workers with sort of hand rakes or shovels to push the stone in. And then placing the panels is really quick work, almost always faster than actually infilling those panels. So it's not really a concern to have the stone catch up to the workers. Usually those workers are going to go a lot faster. Typically, we say a crew of 4, so 4 laborers and then plus 1 operator, will get in around 1,000 square feet of material in about an hour. So gives you sort of a base starting point of how installation would go. And then they placed asphalt on top of the GeoWeb panels. So a regular asphalt paver was used. It was compacted with a standard smooth barrel roller. As I said, no special equipment, no special procedures are required when paving over the GeoWeb system. So your regular asphalt crew can install at their regular speed. They don't need extra training. They don't need to take it slow. They don't need to wait for cure times, anything like that. Okay, one more project here. This was for the port of Buenaventura in Colombia, and it serves as a storage for both coal and containers. So the project consisted of both an access road and a storage area. And again, it had a very low CBR, and the owner contacted us to provide a base stabilization for the whole port. So our solution this time included a 6-inch GeoWeb panel and local fill material. And we were able, since the GeoWeb was able to reduce the stress on that subgrade, we were able to reduce the depth of the pavement from 8 inches to 6 inches, so a 25% reduction. Comes out in total cost savings for the owner in the end. Everybody likes that when you're going for value engineering. Once you fill in the panels, as I said, you can take a smooth barrel roller over that wearing surface, sort of help compact the stone into the GeoWeb panels themselves. You don't need to go cell by cell doing compaction. That would be awful. So yeah, just your standard smooth barrel roller is going to get the trick. So here's what it looks like right before they decided to start placing the asphalt. So they had the smooth barrel roller go across. Everything's nice and smooth, ready for a good, clean asphalt surface. And then here's what that looked like. And so the key to this project was to provide that stable base layer. And in the end, they were actually even able to reduce the thickness of the asphalt. So they were able to go from a 6-inch asphalt surface to a 4-inch. So nice little extra savings there. GeoWeb cells are also great for roller compacted concrete. This was a facility down in Florida. So this project was an intermodal construction design for Florida East Coast Railroad. So in this photo, you can see there were some heavy gantry cranes that were being installed with roller compacted concrete in the craneways. So the original land improvement strategy required 8 months of surcharge loading over most of the site to accelerate primary consolidation and protect against excessive differential settlement. So as expected, that long time frame to implement the preloading strategy was deemed unacceptable by the project owner. So since this was a design build project, Presto was asked to be part of the team to generate a cost savings for base stabilization and long-term settlement concerns. So we worked closely with the engineer and contractor to create the GeoWeb cross-section for those purposes. So the first feature was the ability to use an inexpensive sand infill to replace the specified and expensive 3/4 crushed limestone that would have had to be imported to the site. So specified geogrids that they had hoped to use required that use of high quality aggregate, and that was just going to be too much in terms of hauling costs, getting all that stone to the site, and then the actual cost of the stone themselves. Then the second main feature was the ability of the GeoWeb system to control both short and long-term differential settlement to extend the life of the pavement. Through the mattress effect, which we've talked about, the GeoWeb system behaves like that semi-rigid slab to improve that load distribution and reduces the vertical stress. So it's altering that stress bulb that we looked at way back at the beginning. And so this reduces the overall magnitude of settlement, but also protects against the damaging effects of differential settlement, allowing for primary consolidation of subgrade materials to occur in a much more uniform and controlled manner. So the end result is a much more durable system with a longer pavement life. And so in this case, the design initially the design for the GeoWeb system consisted of a 6-inch deep GeoWeb filled with that local sand material, so they didn't have to bring in that expensive engineered stone, and then a sand cover, so they just overfilled the GeoWeb panels, and then put in roller compacted concrete on top of that. So here you can see the sand being filled in, and then it's filled in with the front end loader pushing that sand into all of the cells. And so you can actually see a compacting roller in the back, allowing for that sort of staggered installation process that we've talked about a little bit. It's great to have this sort of staggered subsequent installation to help reduce your construction time. And then they did roller compacted concrete on top. And RCC pavement is actually sort of an interesting wear surface. It's essentially a low slump, high PSI concrete with no internal reinforcement. So it typically goes down in lifts between 8 and 10 inches. And it is becoming a lot more popular in intermodal and port areas, but it does have a lot of base strength requirements, which is why it's great to use the GeoWeb system underneath. And so here's right after the placement when those rollers are compacting that concrete. So you have that nice, very durable surface. And so by using the GeoWeb system, they were able to reduce the depth of the roller compacted concrete from 24 inches to 18 inches. But more importantly, the construction only required 2 lifts of concrete rather than 3, because they were able to do it in 2 9-inch lifts rather than having to do 3 8-inch lifts. So definitely a huge time and cost savings by that reduction. And so all of our GeoWeb system solutions are done using the AASHTO 93 design method, and we do provide full calculations for you to review. So you know that this isn't just us sort of willy-nilly saying, yeah, it'll work. We do actually have these calculations to sort of back up and prove why our system is going to help reduce the depth of your base and provide you the strength for your roadway. And one of the biggest questions we always get is going to be about cost. No surprise there. So this is really, especially if it's a new technology to you or your area, having an idea of how much the GeoWeb system can cost compared to other stabilization techniques is really important. So here we have just a really basic comparison for the GeoWeb system for load support applications. So the comparison is going to be for the difference for both price and cross-section depth for an aggregate only, a GeoGrid and GeoTextile reinforced section, and then two different GeoWeb reinforced sections. One using a good quality 304 aggregate and one using on-site sort of salvaged, reclaimed material that you don't have to pay for and haul in. And so you can see that the GeoWeb system is going to be both thinner and less expensive than the other methods, significantly so when on-site material is used. So when you can salvage your material, when you can use local sands or your poor quality aggregates, you can have a huge realized cost savings. And so this can be great compared to the GeoGrid reinforced section, which does not allow you to use things like sands as your material. And so, of course, your costs may vary, and distance to quarries can affect things as well, but this does give you a general idea of the savings, both cost and cross-section wise, that can be achieved. So in summary, the GeoWeb load support system can be added to projects to provide a more stable and durable surface course for unpaved areas, reducing your maintenance and repairs. And then for paved surfaces such as asphalt, reinforced concrete, and roller compacted concrete, the GeoWeb system can reduce the pressure on the subgrade to reduce differential and long-term settlement to extend the lifetime of your pavement. The ability to use those low quality aggregates and sandy materials can save a significant amount of money and time. And additionally, the ability to reduce the stress on the subgrade can reduce the final thickness of your pavement. And we do offer complete system solutions for roadways, parking lots, intermodal yards, and other load-bearing applications for your specific project details and conditions. And part of our complete solution is our technical assistance. So we provide free project design evaluations. So the form is on our website at prestogeo.com. You fill it in with as much information as you have. You can attach documents such as geotechnical reports or site photos, and then it comes to myself and the rest of the engineering team. And within just a few business days, we provide that complete evaluation. And so this is going to include things like anchorage requirements, geotextile recommendations. It's going to have those supporting calculations as you need them, all of that good stuff. And we are going to work with you to get the best design for your project needs. Then I would also like to introduce our brand new web-based software, PrestoGeo P3, where you can plan projects yourself within this portal. So this is a software that offers a suite of geotechnical calculation tools designed to support engineers, contractors, and project owners in completing value engineering evaluations using the GeoWeb GeoCell system that we covered today, and then also our porous pavements using GeoBlock and GeoPave, which we did not talk about today, but we can always answer questions about if you are curious. So check out the software today. It's at prestogeop3.com. And we do deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications, so you can deliver certainty and build with materials that you can trust. No disclaimers, no concerning fine print. So that's my presentation. Thank you so much for attending. Hope you learned something. Hope I didn't lose you too much as we went through. I know I was talking kind of fast by the end. Little bit of housekeeping. We are making it faster and easier for you to obtain your PDH certificates. You do get one PDH certificate for listening to me talk today. So with our webinar dashboard, you can easily view our library of webinars and download PDH certificates for any on-demand webinars that you were completed. Your webinar dashboard will keep a record of on-demand webinars completed and those PDHs that you've earned. So in 2 to 3 days, so by the end of this week, you will receive an email from Presto Geosystems with more information about accessing that webinar dashboard, along with some other helpful resources. If you attended live today on Tuesday, August 29th, you will automatically receive your PDA certificate for attending this webinar. It will come to you in about 2 hours directly from GoToWebinar, not from Presto Geosystems. And it's going to have a link for downloading your PDA certificate. So again, it is from GoToWebinar. So if you don't see it in about 2 hours, check your spam folder. Sometimes it goes there. It gets caught up in firewalls pretty frequently. So that's sort of housekeeping for PDA certificates. This webinar has been recorded and it is going to go up on our webinar dashboard. So if you missed anything, if you just want to hear more about this topic, or I guess the same about this topic, you can go back and listen to it there. And then we're also going to get into a Q&A session here. I do realize I have taken up pretty much my entire hour. So if you do need to go, I want to say thank you so much for attending. The Q&A session is also being recorded, so you can check that out on the webinar dashboard when you have time. Or if you have time today, feel free to sit and let's get a copy, or let's go through some of this. Sorry, excuse me. So a lot of questions about using the geotextile underneath the GeoWeb panels. When you would use a woven, a non-woven, when you might use a GeoGrid underneath, why you would use it, why you wouldn't choose. So lots of questions surrounding that topic, and it is a really good question. I will say it's never anybody's favorite answer, but there is no one right solution. So I can't just say, this is the answer, here you go. We do recommend that you come talk to us about your specific projects, and we'd be able to help you determine what's going to be appropriate for you. But in general, you're going to want to use a geotextile or a GeoGrid underneath when you have those really, really soft subgrades. We're talking CBRs of less than 1%. So when you can walk out on site and your footprints are sinking down into the muck really easily, that's when you know you have really soft subgrade, and you're going to want to have that little bit of extra reinforcement. And using those geotextiles helps spread the load, so it helps with that mattress effect that we talked about, helps prevent punching of the system into that soft subgrade underneath your vehicle tires. You obviously don't want it to just sink down into the muck. Having that geotextile can help prevent that. And it also helps with preventing material loss underneath the system. So especially if you know you're going to have a lot of water movement underneath the system, if you are in a saturated environment, using the geotextile can help make sure that you aren't going to lose your stone or your aggregate infill from the panels to that water movement. And that's typically why we would recommend using a woven geotextile. Woven geotextiles allow for that free water movement without getting clogged. Non-woven geotextiles are cheaper, but do have the potential to get clogged, especially if you're in a very clayey environment, which could lead to potential problems down the line. So our typical recommendation is going to be woven geotextiles. Let's see, some other questions. So what do you do when you have greater vehicle loads? So if you're having incredibly heavy vehicle loads greater than what would typically be allowed on a highway. So that's going to be really specialty construction equipment. Crane loads are really common for those really heavy loads. Those big reach stackers are going to be heavier loads, that sort of thing. And that is acceptable. So you can have those incredibly heavy loads, and we just need to work through it, make sure that we have a cross-section that is going to be strong enough to support those loads. So I do encourage you to reach out to us directly and say, hey, I'm working on a mine site, and so we've got those massive mine hauler vehicles. How do we support those as we're going, to and from our mine site? And we can help determine, based on your specific project conditions, based on the vehicles that you anticipate being trafficked through the area, we can determine that cross-section. Usually it's going to result in a bit of a thicker cross-section, so you're going to have some sort of base layer underneath. But having those incredibly heavy loads is not a deterrent. We're not limited to, cars and pickup trucks. We can go the full gamut of pretty much any type of vehicle, wheeled and tracked. Some questions about, how do you handle stormwater in the system, and what kind of stone is going to be appropriate for that. And so that sort of is two interrelated questions. So we'll start with what type of stone do we recommend when you want that permeable pavement, when you do want the water infiltration. And really you're going to want an open graded stone. So that's going to be something with very limited fines content, fines content. So think 10% or less, but really even up to 20% fines is going to still allow for some water infiltration. And that is leaving those void spaces open between the stone to allow for that water movement down through the surface. And then you're going to want some larger stone to make sure you do have larger void spaces. So you're not really going to be wanting, half-inch stone, because that's going to still be pretty compacted, it's still going to have minimal void space. Typically something like a 2-inch stone is going to give you a lot of good void space, can have that minimal fines content, allow for good water infiltration. And the storage of stormwater is going to be based on your voids content. There's no surprise there. So typically, depending a little bit on your stone gradation, if you do have that good 2-inch stone with minimal fines, you're going to have a void space between 30, potentially all the way up to 40, 45%. And so you can fill that whole void space with water as your water storage while it sort of slowly infiltrates into the ground during your stormwater events so that you don't have surface runoff. And so the good thing about the GeoWeb system is that the GeoWeb panels themselves take up virtually no space and they don't have any sort of hard surface. So the whole thing is basically open graded stone, allowing for that water infiltration, allowing for that high void space to allow for that storage, natural infiltration into the groundwater system. So if you do have specific questions, especially if you have, local regulations where, my city says I need to meet, XYZ regulations for this to be considered a porous pavement, please feel free to reach out to us. We've been doing this a lot. We've been doing this pretty much all over the US and the world. So we have some really good experience with it. We have, some of the tools and some of the, the key words that a lot of those regulators are looking for to make sure that this actually meets your local standards. Let's do one more question because I've gone over time here. So basically, how is this considered a cost-effective or a value-engineered solution compared to your traditional methods? How do you come in with something like this that maybe you've never seen before, maybe your project owner has never seen before, and convince them that this is going to be the right way to go? And it really comes in twofold. And one is your installation costs, so your actual materials, potential hauling costs, time of installation, that sort of thing. And so while the price of the GeoWeb material itself, the actual panels, is going to be, more expensive than just looking at, bulk stone material that might, throw up some red flags. Oh gosh, it's so expensive. The idea is that you need to consider it holistically. You need to consider that you're going to get a thinner cross section. So that's less excavation. That's less materials needed to fill in the cross section of the road. It's going to be less time for that installation. So you're going to get your crew out. They're going to get things in faster. You're going to get back to work a lot faster. And then you also need to think about it long term. It's going to be that reduced maintenance. It's going to be, that less materials having to come back in and constantly fix rutting or potholes, anything like that. So you have both your immediate cost reductions and your long-term cost reductions. Like I said, the GeoWeb panels have been tested and are going to work for 100+ years. That's going to meet pretty much any project requirement. I can't think of many that are going to say they need to last longer than 100 years. So you know that this is going to be something that you can put in once and it's going to work. You can just basically place it and forget it. So it's definitely something that I encourage you to think about when you do have these sort of value engineered options, or when you're trying to think of, innovative solutions to a problem that you're just running into, cost overruns, time overruns. This is a great way to try and solve some of those issues. So if you had other questions that I didn't get to today, I apologize. Please feel free to reach out to me. My information is on the screen. You can also go through our website. We have a contact us and all of that good stuff on there. I would love to answer your questions. I would love to talk to you about specific projects, but we have gone over time. Thank you, anybody that has stayed with me. I hope you learned something today. I hope you attend some of our future webinars so that you can keep learning about the GeoWeb system. And I hope you all have a wonderful day. Bye.